Okay, well, welcome back, and so let's just keep moving along. So here I've created another board. I've added a few more circuits. The most important thing to note is that I've added another 10K pull-up resistor, which you can see here, and it's hooked to the positive bus, which, if you recall, okay, this end of my board, the ground's across, the positives are across, so both of the main buses are connected. And from here you can see that voltage is being supplied from the Pro Mini down a positive bus. And the thing I've added here is I've taken pin 11 and I've added an additional wire, this additional 10K pull-up resistor hooked to the positive bus, and another one of my homemade switches. Okay, so you can see what happens. Let me get this lined up a little bit better. There we go. That if I ground out the voltage, which is now going through the resistor to the pin, telling it to be high, it will now ground and it's going to be low. And if I do this other one, it's going to be low. Now, what is a little bit of a challenge here, which is why I did this, is now we have basically three different states. You know, the last program I did an if-then statement, which was simple. If this, then do that, else continue to move on forward. All right. Well, now I have an additional if statement going on. So if I do an if-then here and an if-then there, the problem is that when you go to a loop, as we do in Arduino, it's still going to go down the loop. So I can do an if-then statement, and it's going to say, okay, if this, then do it. But then it's going to proceed down. Okay? So you end up getting this sort of broken code, which doesn't work really well. It really kind of mucks it up a bit. But before I get into that, let me show you what else I've done here. I've created two booleans, in other words, true or false statements. I have a boolean called switch1, SW1, and a boolean called SW2. I've also created two subroutines. So if neither switch is on, so in other words the switches are off, it's going to go ahead and do this routine where the two lights move through an array, which is what you see right now. Okay, so that's sort of the resting state. If switch 1 goes high, or goes on, it's going to flash. Keep in mind, you see those ones there because these two right here are dedicated to that transmit or receive function on port D. And in this case, if switch 2 goes on, it's going to flash the two highest bits on port D and the two lowest bits on port B. I've done this both ways again. So these two are equivalent. This is remmed out, so you can't really, it's gray, but you can always remove these symbols. You can see I have all these set to output. These two on port B are set to output, and all the rest of port B is currently set to input. Okay, let's look at the code. It's really pretty simple. All right. First thing it does is it checks, hey, are you high or are you not? Okay. It looks at pin 10, which is this pin here, which is hooked up to this resistor, which currently is high because it's not grounded. All right. Then it goes to the second one. Hey, pin 11, are you high? All right. And you can see it's currently got supply going to it, and it's currently fed through. It's high. All right. So then what we do is we do a check. A boolean is true or false. Okay. If switch, I should have done this in different order, but it'll work the same. If switch 2 is absolutely, positively equal to false, all right, and on the bitwise level, it's saying yes, it is absolutely a 0. It is low. then I want you to run this subroutine. Okay, so if we look at it, it's going to flash these lights. If switch 1 is absolutely positively set to 0 or false or low, all right, it's going to run this subroutine. Okay? If both, this is an important thing, this is how you kind of make multiple, you can make a really, we can do it with a switch statement in various other ways, but for the moment, let's stick with this. We'll move forward as time goes on. If switch 1 is absolutely positively high, and notice that when you double it up, you're talking about bitwise operations. You're talking about logical stuff here. I tend to think of things like, I can say that I have $1 in my wallet. I can say I have 1. You're smart enough to know that if I say I have 10 minus 9, well, that's equal to 1. Well, the computer wants to know exactly what you're talking about. So if it is at the bitwise level, if it is absolutely positively true, it is high, all right, on that 1 bit, okay, and there's no ambiguity here. It's a double and, all right? It is and. It's at the logical level. It's at the bitwise level. Switch 2 is also true, okay? Both of those are not grounded. Neither one of them are grounded. Then let's go ahead and run switch off, which is here, okay? So I think I'm not even going to change anything because it's pretty good. I'll post this. I hope that makes sense, and I hope you can follow it along. And we're going to continue to move forward. So I will see you shortly.